the story of an automobile that will never see a production line. FIREBIRD III, an experiment for tomorrow. It's the story of the General Motors research, styling, and engineering staffs working together as a team at the vast General Motors Technical Center. Here, in an atmosphere conducive to search and discovery, GM men of ideas work for a better tomorrow. One such man is Bob McLean, a styling engineer.
FIREBIRD III is the third in a series of experimental cars we have helped design here at General Motors Styling. FIREBIRD I was a high-performance vehicle and reflects the sweeping lines of a jet fighter. FIREBIRD II was styled as a family car with additional engineering features. In designing FIREBIRD III, our job at Styling is to integrate the new developments of research and engineering into a fully operational, eye-appealing car. We start with a man, Oscar, and design the car around him. Basically, we need a passenger capsule and a power package. By putting a control stick here at Oscar's side, we could develop a new means of entry and give Oscar a semi-reclining seat to put him in the most comfortable driving position. For the power package, we decided to put the latest research gas turbine engine here, behind the passengers, and simplify the powertrain. We knew, too, that the accessory load would be high. So to run the generator, pumps, and other equipment efficiently at a constant speed, we use a small piston engine. This allowed us to unify the accessories in the best available space. Then the arrangement of these elements is checked to assure satisfactory weight distribution.
The styling section is also working to give FIREBIRD III a shape and a look. Stylists Norm James and Stefan Habsburg help conceive its futuristic lines.
We start with basic theme sketches, preliminary ideas that help us over the first formative stages of design. Then, we translate these sketches into side views of the car, using these fluid lines of colored yarn to work out the various combinations of curves. Change only a pin, and in an instant, we can change the entire character of the car. In this way, we arrived at the basic silhouette of FIREBIRD III.
And so FIREBIRD III takes shape at Styling. Nearby, the engineering staff and the research laboratories are designing and building the many advanced features that will be incorporated in this experimental car. Joe Bidwell is one of the men who helped task force this project at Research.
We at Research think of FIREBIRD III as an experiment, an opportunity to integrate and try out ideas. Many original engineering features have been incorporated into this chassis. The frame, for example, with its rigid spine and wishbone construction to accommodate the passenger and engine arrangement, and the unique front axle and steering mechanism made possible by this fully powered control. Unicontrol is a new concept in steering, designed to simplify your driving task. This system uses specially developed electronic computers to control hydraulic power servos which actuate the brakes, throttle, and steering. Push forward to accelerate, steer left or right. Pull back for braking. Rotation of the control knob selects forward, reverse, or park. There is no mechanical connection between the control knob and the front wheels, but car motion feedback is supplied to the driver by the mass of the knob. To this, we have also added auto guide, an automatic guidance system, and cruise control. Two pickup coils mounted under the front of the car straddle a current-carrying wire embedded in the highway. The coils receive signals that are fed to the steering system computer in the electronic control and electric power center. The electrical signals are converted into hydraulic power at this servo valve manifold to guide the car along its course. Electrical and hydraulic power for all of the controls and accessories is provided by this small accessory drive engine, a significant development of both the research and engineering staffs. Here, advanced wear-resistant aluminum alloys are used to give FIREBIRD III a compact, lightweight power plant independent of the gas turbine engine. Another outstanding feature is the FIREBIRD's turbal brakes. Here, wheel and brake drum are combined. This test shows how cooling air enters the hub and is forced through a series of air cooling passages. This brake mechanism and a new anti-skid device gives unsurpassed driving security. To give FIREBIRD III a smoother ride and better roadability, the research laboratories have designed a high-pressure air oil suspension system in which the front and rear springs are interconnected to suppress pitching motions of the car. These springs are connected to the large axle tube here. The wheels are driven by short shafts from the chassis-mounted powertrain. These blowers cool the engine oil and provide the engine compartment with circulating air. This is the WorldFire GT305, the most compact, efficient gas turbine automobile engine today. Bill Turunen directed its development.
Essentially, it's quite simple. Air is drawn through the compressor here to the burners where combustion takes place. The hot compressed gases then expand through a set of windmills or turbines developing power. One turbine drives the compressor, the other turbine drives the rear wheels. The regenerator, consisting of metal mesh drums, salvages most of the heat in the exhaust gas and returns it to preheat the incoming compressed air. By using this waste heat, we can greatly improve the engine's efficiency. This is the heart of FIREBIRD III and represents a significant step forward in gas turbine design, one of the many steps we have been able to take at the research laboratories during the FIREBIRD III project.
This, then, is FIREBIRD III, as expressed in the ideas of the men who designed this experiment for tomorrow. Ideas that must now be translated into a fully operational car. Wooden mock-ups of the car's many parts are constructed. Clay models reproduce every detail of the Firebird's body. Carefully formed plaster casts bring life to the sweeping lines of the stylist. FIREBIRD III in 3 dimensions, now ready for testing in the wind tunnel. In the research laboratories, the chassis is assembled. Developments of the many General Motors groups now come together to work together in FIREBIRD III. And soon, the stylist, researcher, and engineer can see his ideas take shape in sweeping lines of fiberglass and steel. And this is the realization. FIREBIRD III, functional beauty today for tomorrow. And now, tests at the General Motors Desert Proving Ground in Arizona. Test to prove out the forward-looking designs, the ideas embodied in this experiment on wheels. Constant testing around the clock until Firebird III is ready for the acid test. So get ready for a ride in Firebird III. You are here. Squeeze your sonic key and sound waves open the door. The sonic key is also used to start the car. First, the small accessory engine. Then, the gas turbine. Brake flaps provide additional braking. You're ready now for the driving thrill of a lifetime. Want to sit back and relax? Well then, set in the speed you want to drive and switch over to automatic guidance. Release the stick and Firebird III is on its own, receiving its commands from a wire in the road. This certainly is the future, your future, brought closer today by the Firebirds. Firebird I. Firebird II. Firebird III. Experimental cars, conceived and built to acquire the knowledge and skill General